want to work a couple examples of derivatives here involving hyperbolic trig functions and other things just to show how it all, works together. So for instance, here's a function, x squared times hyperbolic tangent of x. What's the derivative? Well, it is a product, so I need to use the product rule. I need the x squared times the derivative of the inverse hyperbolic tangent, and the derivative of the inverse hyperbolic tangent is 1 over 1 minus x squared. So that was the first times derivative of the second, plus the second times the derivative of the first. Well, the derivative of the first is 2x, and then times the inverse hyperbolic tangent. This could be written a little differently with the x on the top there, but essentially that's that. Next one I want to do is something like y equals the inverse hyperbolic sine of 3x. How do I take the derivative? Well, this is a chain rule, right? This is a inverse hyperbolic sine, of u, where u is equal to 3x. So I need the derivative of the outside function, leaving the inside alone. So the derivative of the inverse hyperbolic sine of u would be the square root, 1 over the square root of 1 plus u squared. Well, u is 3x squared. Right? So if this was just an x here, then this would just be an x, but it's a 3x, so you replace that x with a 3x. That then multiply by the derivative of the 3x, which is 3. So we end up with the derivative of this function is 3 over the square root of 1 plus 9x squared, because the 3x gets squared to be a 9x squared. Okay. Anyway, all the rules that we've learned, product rule, quotient rule, sum rule, difference rule, chain rule, sines and cosines, all work together and play nicely with these new hyperbolic trig functions and inverse hyperbolic trig functions.